Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So in our today's video, we will discuss about the isotopes and their relative abundance. So isotopes. When we have a look on any pure substance, so that pure substance is mainly an element, and an element is consisting of same type of atoms. But here we have an element whose atoms have same number of protons but they have different number of neutrons. So the atoms that have same protons and different neutrons, these are known as basically isotopes. Before that, you guys must know the structure of an atom. When we have a look on the structure of an atom, it is basically consisting of the central part, which is known as the nucleus, and around the nucleus we have the circular orbits, and these circular orbits have negatively charged electrons. Now, these are the electrons and the central part, which is having protons plus neutrons. So, the isotopes are basically formed on the basis of the number of protons and number of neutrons. So, here we have the atoms whose protons number is same but they differ in number of neutrons. On the basis of this, the isotopes have been discovered. Now here we have the example of isotopes of hydrogen. Hydrogen, its symbol is capital H. In the first one picture, we can see that in the central part, the first one we have hydrogen 1, we have hydrogen 2, and we have hydrogen 3. The first is having just one electron and one proton, and no neutron is present in it. So this is the first isotope of hydrogen and its name is protium. And the second isotope of hydrogen we have it is one electron, one proton and one neutron. So this is the second isotope of the hydrogen. Its name is deuterium. And the third one isotope of hydrogen we have tritium, and the tritium is having one electron. It has two neutrons and one proton. So in all, we have just proton number is equal to 1, but they differ in the number of neutrons. In the first one, we have no neutron, in the second one, we have 1, and the third one, isotope of hydrogen, is having 2 neutrons. So on the basis of the difference in the number of neutrons, the atoms may have differ or may differ in mass number. So when they have different mass number, they are called as the isotopes of that element. So this is a simple about the isotopes. Next we have the isotopes of other elements. Isotopes of other elements. First one we have chlorine. Chlorine have just two isotopes. The number one we have chlorine 35 and the second one we have chlorine 37. As their atomic number is same, that is 17. So 17 is their atomic number, that is denoted by Z. It is 17 and their mass number is denoted by A. The first one we is having 35 and the second isotope having 37. So they differ in the number of neutrons. Have a look on this. The first one is having protons 17 and neutrons 18, and the chlorine 37 have protons 17, that is same but different number of neutrons. It has 20 neutrons and it has 18 neutrons. So both differ in the number of neutrons. And the second example for the isotopes of carbon, we have carbon 12, 13 and 14. First one, carbon 12, it has 6 protons and 6 neutrons and its mass number is 12. And this carbon 13 has 6 protons and it differ in neutrons, that is 7 neutrons, and its mass number is 13. The third one we have carbon 14. It has 6 protons and it has 8 neutrons. So it is having 6 neutrons. Carbon 13 has 7 neutrons and the carbon 14 has 8 neutrons. So all these just differ in their number of neutrons. So this is the basically base for the isotopes, that how they have been discovered. There is a change in their number of neutrons that is present in the nucleus. Next we have the relative abundance. Now what does mean by relative abundance? Basically relative abundance is the natural abundance. It is the natural abundance of the isotopes, that what is mainly the percentage of isotopes is present in nature. This is called as the relative abundance of the isotopes. For the relative abundance of the isotopes, we have here the formula, and the formula we have relative abundance of the isotopes. We have to take the summation of isotope abundance, multiply with the isotope's mass number and divided by the summation of the total isotopic abundance. Likewise, here we have the presentation of relative abundance along y-axis, and we have the relative mass of the isotopes along x-axis. So here we have the two isotopes of chlorine, chlorine 37 and chlorine 35. So the relative abundance of chlorine 35 is almost 75% and of 37 is 25%. So how we can find its relative abundance? So we will apply it to the formula. First isotope abundance of chlorine 35 we have 25. Multiply it with the isotope mass number. Its mass number is 35. Summation with the isotopic abundance of chlorine 37. It is 70, 35 or 37. So here we have for the 35, which is 25 multiplied by 37, and plus we have 75 plus 35. So here we have to take this summation. So we can write it like this, divided by the total isotopic abundance 75 multiplied by 35 and 37 multiplied by 35 divided by 100, which is the total isotopic abundance. By solving this, we may be able to find the total isotopic abundance or the relative abundance of the isotopes. This is very simple, that how we can find. So just by multiplying 25 with the 37, we gain 925, and plus we have 75 with the 35, 2625 and divided by 100. So the solution for this we have 925 at 2625 and divided by 100. So we have its mass number 35.5. So this is the relative abundance of the isotopes. So basically this we call it as the simple way to find it. So this is all about today's video, and if you guys have any queries, so we can have the comments in the section. So this is all about today's. In the next video, we will discuss about the mass spectrometry. That time, have a good day and Allah Hafiz.